Okay, so today we're going to talk about radical equations. Okay, so today you're going to learn how to solve an equation with a radical and also how to do it with rational exponents. So to solve a square root equation, we want to get the radical by itself on one side of the equation, and then we're going to take the square root of both sides, and we're going to check for extraneous roots. So here's an example. I want to move the 5 over to the other side, so I'm going to add it to both sides so that I get 4x plus 1 equals 5. And now I'm going to square both sides. When I do that, that gives me 4x plus 1 equals 25. If I subtract 1 from both sides, I'm going to get 4x equals 24. And if I divide by 4, x will equal 6. Now the last step I said was to check for extraneous roots. So you always want to check these examples. I don't care if you do it via the calculator. I don't care if you put it in and check, but you always need to check these. So we're going to put 6 in for x, and we want to make sure that it equals 0. So 24 plus 1 minus 5 is 20, square root of 25 minus 5. So 5 minus 5 is 0, so it checks. And we're only going to check with the positive or the principal root. All right, so to solve this problem, I'm going to bring the 3 over to the other side. So I'm going to get the square root of 5x minus 1 equals x minus 3. I'm going to square both sides. And when I square both sides, I'm going to get 5x minus 1 equals x minus 3 times x minus 3. I'm going to do some scrap work over here, just because I don't want to write 5x minus 1 over and over again, because I'm a little bit lazy. And you're going to multiply these binomials however you multiply them. So if I distribute, I get x squared minus 3x minus 3x, and then plus 9, or x squared plus 6x, minus 3x, 6x, plus 9. And then I get 5x minus 1. So I'm going to add 1 to both sides and subtract 5x from both sides. And that's going to give me 0 equals x squared minus 11x plus 10. Right? And I can solve this easily by factors, because the factors of 10 that add to negative 11 are x minus 10 and x minus 11, or minus 1. If I set those factors equal to 0, I get x equals 10 and x equals 1. Okay. Now, we could have extraneous roots, and those are caused whenever we are dealing with squares and square roots in imaginary numbers. So I want to check. I don't care if you check by calculator. I don't care if you write it out and check, but you need to check. So if I just put 10 in, I'm going to get 5 times 10 minus 1 plus 3 equals 10. So 5 times 10 is 50 minus 1, which is the square root of 49, plus 3 equal to 10. 7 plus 3 equals 10. So we know that that checks. So 10 is one of our solutions. If we put in 1, and again, we're only looking at the positive roots. So 5 times 1 minus 1 plus 3 equals 1. And common sense should tell you that's not going to work, because I'm going to get the square root of 4 plus 3 equals 1, and 2 plus 3 does not equal 1. So that is not a solution. Okay. Now when I've got exponentials, okay, it's easiest to take each side to its power, to the reciprocal of the power. However, when you do that, if either my m or my n is positive, then what's inside the parentheses, we've got to apply that absolute value to it. So it would be the absolute value. So to solve this example, I'm going to divide by 2, and I'm going to get x plus 3 to the 2/3 equals 4. And then I'm going to take both sides to the 3/2 power. Okay, when I do that, we're going to be left with the absolute value of x plus 3 equals 4 to the 3/2. 4 to the 3/2 is the same as the square root of 4 cubed. The square root of 4 is 8, or excuse me, the square root of 4 is 2, and 2 cubed is 8. So I have the absolute value of x plus 3 equals 8, and I've got to write two equations. X plus 3 equals 8, x plus 3 equals -8, and I have to solve those. So x equals 5, and x equals -11. So again, you want to check those roots. So 2 times, and I'm just going to write this as the cube root of this squared equals 8. So 5 plus 3. So 2 times the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4. So 2 times 4 is 8. So if any of you are wondering how I did that, the cube root of 8 is 2. And 2 squared is 4. If I put in 11, 2 times the cube root of -11 plus 3 squared equals 8. So I get 2 times the cube root of -8 squared. The cube root of -8 is -2, but -2 squared is 4, and again 2 times 4 is 8, so actually both of these are solutions. Right? And our last example, notice in this case we have 2 radicals, so I'm going to move 1 to one side and 1 to the other. So I'm going to get the square root of 5x plus 4 equals 4, and I'm going to add the square root of x. So now I'm going to square both sides. When I do that, I'm going to get 5x plus 4 equals 4 plus root x times 4 plus root x. And again, I'm going to do some scrap work over here because I'm lazy. Okay, so when I distribute, I'm going to get 4 times 4 is 16. Distribute again, I'm going to get plus 4 root x. Distribute again, plus 4 root x. And the square root of x times the square root of x is just x. So when I simplify that, I'm going to get 16 plus 8 root x plus x. So I still haven't gotten rid of all the square roots, so I'm going to bring everything to one side. And I'm going to subtract 16 and subtract x from both sides. So I'm going to get 4x minus 12 equals 8 root x. Now I could divide everything by 8, but that's going to give me fractions, and I'm not going to deal with fractions. You know, it's the one of the F words of math, fractions and factoring. So what I'm going to do is I'm going to square both sides. And I'm going to get 4x minus 12. And then when I square this, I'm going to get 64x. And I lied, because when I square 4x minus 12, I've got to rewrite it as 4x minus 12 times 4x minus 12. So when I multiply all of that out, by now hopefully you know how to multiply all that out, I get 16x squared minus 96x plus 144 equals 64x. Again, it's a quadratic, so I'm going to subtract 64x from both sides. And I'm going to get 16x squared minus 160x plus 144 equals 0. Make it easy on yourself and divide everything by 16 so that I get x squared minus 10x plus 9 equal to 0. And then I need factors of 9 that add to 10. So x minus 9 and x minus 1 equals 0. Setting those equal to 0, I'm going to get x equals 9 and x equals 1. Okay. And then I've got to check to make sure that they work. So I'm going to plug them in to the original equation. The square root of 5 times 9 plus 4 minus the square root of 9 equals 4. So 45 plus 4 is 49. So square root of 49 minus 3 equals 4. 7 minus 3 equals 4. So we know that 9 is the solution. If I plug in 1, I'm going to get the square root of 5 plus 4 minus the square root of 1 equal to 4. And 5 plus 4 is 9, square root of which is 3. 3 minus 1 does not equal 4. Okay. So that means that this is not a solution. So you only have one solution. So these can be quite a bit of work and quite a bit of steps. Okay. But we learned to solve a radical equation today and one with a rational exponent. Have a math-tastic day! Yay!